Hello, my fellow YouTubers. This is Roy back again. Quick display of my command center. These up here are DC meters. These two are AC. This one here is a time delay, a digital time delay. This here is a DC motor controller. This here is to knock down the voltage. So over here we have, you see on this one, 12.65. They're all both feeding off of that battery. And this one here is feeding this, and that is taking some usage and 0.02 current to run that. Over here, pretty cool, on my switching, or not switching, but my switches. This is my LED controller. I have an app on my phone, and I can control the B, the G, the R, and the W on these settings here with my phone from anywhere. This here is potentiometers. This whole row is 1K. This whole row is 10K. I'm gonna have 5 switches. I got 3. I got my authentic switch, my knife switch. Something I'll show you real quick is we now have the oscilloscope hooked up to the coil here. So when I spin this, I get a heartbeat. Yeah, I can't get both in. Anyway, I'm gonna spin the wheel. And you can see we are working on this bottom coil. And you can see we have a heartbeat now. Yeah. So this here is going to be our gyroscope / Bedini wheel. Moved it over from over here, from the bicycle forks. We have, let's see, we also have this other additional 2 coils that will go crosswise. And by having those, I can dial in like a distributor. I can do advanced timing, and I can also do retard timing. You get that wheel turning again. I don't have anything hooked up. I am just excited about my new command center. We're doing this because it's time for empirical data, and basically we're going through everything. I got a lot of stuff here. That's a 3-phase rectifier. There's a analog meter that goes up to 3 volts. There's my oscilloscope. That's analog, not digital. There's my my frequency generator, so we can control frequencies. This here, which is very cool. This is about empirical data, and this here is a scale. It's a digital scale. And that digital scale will tell us the pull strength that it takes for me to move this wheel against the induction. So we'll have our own little test on how much pull strength it'll have. It's like my little spinny thing. It's always been inspirational. The other thing up here is our capacitance, and something very important is what the plus charges are. And the plus charges are air, our skin, the human hand. So Jason, there you go. On your video, on your older video a year ago, that you had the light bulb light up because your human hand becomes a positive charge. Asbestos, positive charge. Rabbit fur, glass, human hair, mica, nylon, wool, lead, cat fur, silk, aluminum, paper, and cotton. All plus charges. Very important in our studies we're going to do. We're going to dig into it. There's your negative charges. Steel, wood, lucite, sealing wax, amber, rubber balloon, hard rubber, mylar, nickel, copper, silver, brass, synthetic rubber, gold, platinum, sulfur, polyester, polyurethane, acrylic, silicon, Teflon, silicone rubber, polyethylene, all negative charge. Important stuff. Also over here I have my high voltage flyback running off a smaller ZVS driver. Then I got a bigger ZVS driver which has a certain frequency range about it, and it melts metal. And here's my little crucifix. It will melt some bismuth. And we'll get into the kind of test. We'll get into a lot of all this is stuff I've been doing in the last 7 years. And I got a lot of empirical knowledge here, I'm just going to say. And it's time to really just step it up. Got my 4 new neodymium 1-inch squares in, the ones that are on here. So, yeah. 4 more. Those guys are beasts. Let me see, what else? Also, I got a RPM magnetic relay. So what I like about this is when I spin the wheel, look at that meter right there is our RPM meter. So I gotta spin the wheel, 2 hands. Now I'm gonna put this up in front of the wheel. And so we'll have accurate data on RPM, which is very important here. Very important. And I also, in my advanced part of my gyroscope, I'm thinking that when I get this spinning, I also want to do a test for my own knowledge on what if I take a weight, which is 2.5 pounds, or if I take this weight that has a baron in it already, which is 5 pounds, and we do some experiments on the mass and of this weight. I'll put magnets around the outside, get it spinning, set up. That's why I have this right here set up. This pole here will be this one of mass. And we're going to do some tests on going up and down on the weight of this mass versus the weight of that mass. And they'll both have magnets. They will both still be spinning in a Bedini way, but they also would be different. And I think if you follow the data that's out there is that the more mass, um, it, um, it'll have more inertia. So at what point do we start breaking down the where how much inertia do we need? How much of a dynamic situation do we need to be able to get something spinning and something that's able to produce? I love this. Watch the able to produce different effects. And the different effects is one, the gyroscopic effect, that it'll have an axial presence about itself. That's why I took two off, just too much. Right now I'll start off with one as a driver, and we'll start off, get this turning. But I'm not ready yet, because I'm still in the process of setting up the laboratory. This is going to be pretty damn cool experiment. All right, you guys, leave your comments. Peace out.